Objects are where you save your data in R. They can be words, numbers, or any kind of character. Objects can be vectors or matrices. A vector is kind of like a simple table. You have one parameter, or thing that you are measuring. In our table, we have a column of different rainbows and their intensity of the blue. And to visualize this, think of a column of Lego pieces. Each block represents a cell containing a decimal in the table. Using our example in the table about rainbows, 0.5 would be the first block, 0.6 in the second block, etc. A matrix is basically multiple vectors next to each other. It can be thought of as a larger table. Here we have multiple parameters. To visualize this, look at multiple columns of Lego pieces. Each column represents the data for a specific parameter. For our example, it is the intensity of a color in different rainbows. Each row is all the data on the different parameters for one observation. For our example, one row contains all the information about the different color intensities of one rainbow. And now let's talk about the different kinds of objects. Objects can be defined to be numeric, character, or logical. However, let's first go over how to define vectors and matrices. To define a vector, you simply need to type C paren close paren. For example, in our code, on line 3, we have vector.name equals C paren 1, 2, 3, 4, close paren. And then we display the vector on line 4, just restating vector.name. So let's run that real quick. And so that's what a vector looks like in R. And as a reminder, I provide the code used in this example in the description down below. You will need to use the matrix function to create a matrix. To define a matrix, you will also need to specify a few things. You will need to specify the number of rows and columns. You can do this with the nRow and nCol options respectively. So for example, in our code, on line 8 we have matrix.name equals and then matrix, and then inside that the same numbers as before, and then nRow equals 2, nCol equals 2. And then we call that matrix with matrix.name on line 9. So let's run that in R. And so this is what a 2x2 or 2 rows and 2 columns matrix looks like in R. There are alternative ways to define a matrix, however we'll discuss this at a later time. Now let's discuss numerical objects. Numerical objects are simply numbers or that are in the vectors or matrices that can be directly applied to mathematical operations. And so we have our examples of numerical data in R from lines 13 to 23 in our code. So vector 1 is simply the same vector that we did up above. So let's run that again just to be absolutely clear what's going on. So that's what 1, 2, 3, 4 vector 1 looks like. And so we can also define a vector that has 1,000 observations using the rnorm function, which we will get to what functions are at another video, but the idea is you don't have to put vectors in this format that can be made in different ways. So let's run line 18, which creates the vector, and then view the vector on line 19. And so as you can see, the vector goes over many lines, and that's okay. This is normal what it can look like. But it's important that you recognize that this is a vector, not a matrix, because at the top here it doesn't have numbers in brackets like it does for matrix.name. And so now let's again specify how to do a numerical matrix in R. On lines 21 and 22 I create the exact same matrix as I did before, but let's look at it again. And so that's a 2x2 matrix. Now you can view it in a more traditional Excel-like format by using the edit function and putting the matrix in the parentheses. So let's run that line. And so this looks kind of like an Excel spreadsheet, and you can go in and edit it if you would like. Next, we'll go over character objects. Character objects can be numbers, letters, or even sentences, but they are surrounded by apostrophes. So let's look at an example. We have our character data in our examples from lines 27 to 35. And so line 29 defines a vector called vector3, where it has characters as the data in that vector. So it has the number 1 as the first data point, and then the word 2 as the second data point, and then the third data point is 3 the number, or 3 the word, and then the fourth data point is the statement, the number 4 goes here. So let's run line 29 to define this vector, and then let's call vector 3. And so this is what this vector of characters looks like. As you can tell that they're character data because they're surrounded by these apostrophes. And so you can also create a matrix with character data. So let's define a 2x2 matrix using those exact same data points. So we'll do that in lines 33 and 34. And so that's what a 2x2 matrix might look like of this data. And so again, you can look at this data, this matrix, in a traditional, semi-traditional format of Excel by using the edit function, and it looks very similar to an Excel spreadsheet. Lastly, let's go over logical objects. Logical objects are either true or false. They can be thought of as equivalent to the answers yes or no questions. For example, are you a member of the Green Party? The answers are yes, aka true, or no, aka false. So let's look at an example of a vector of logical data, and that's from lines 39 to 42. So we define a vector 4 to be true, true, false, false, true, false. This is logical data because the trues and falses are all capitalized, and R immediately recognizes this to be logical data. So let's run this line 41 that defines vector 4 with this logical data, and then let's call vector 4. And so logical data is just simply capitalized trues and falses, and it's pretty evident to recognize. Thanks for watching my video. Make sure to like, comment, and subscribe. Visit my website RGalleon.com for more R and statistics guidance. You can also visit my Facebook page and follow us on Twitter. Have a good one.